In this video, we're going to talk about the HVAC Schematic 1 wiring diagram that's in the Hydronics part of the program. Okay, so what we have in front of us on the screen now is the wiring diagram, and I call them the connect the dots. Okay, we have a whole bunch of safety switches that you would find in both residential and light commercial applications. We have our circuit breaker, we have an emergency switch that you normally find at the top of the stairs. This is a boiler. We have a Firematic. That's that fusible link sort of safety device that's hanging over a furnace to make sure we don't have a fire. Special line oil. This is an oil primary control. We have the service switch that's on the side of the furnace. We have our aquastat. We have a single circulator with 2 zone valves and 2 thermostats, so it's a 2-zone system. We have our transformer, we have our ignition transformer, and we have our burner. Okay, so the aquastat is actually a burner control as well. We have a CAD cell, that's a safety device. So what we're looking at in summary is a 2-zone system, single circulator system, oil-fired system. So the goal here is to connect this so that it works properly. Now, when we're connecting this, we have to realize and we have to try to wire this as we would if we were standing in someone's basement. Okay, we know that the aquastat is the connection point for all the devices. Okay, so as we wire this, we have to make sure that we start with the line voltage. Okay, now I'm going to do my line voltage in blue just so that it sets it apart a little bit. And I am going to increase the size of my line with just a little bit so that we could actually see it. So from our power source, we have to start off by going to our safety switches, okay? You cannot bypass the safety switches. And safety switches are all wired in series, which is why you see me going down here and doing we're going to connect everything in series. If one switch is open, nothing else will get power. Okay, coming out of our safety switch from L1, okay, I am going to come up and I'm going to connect into the terminal L1. And again, if you're drawing this in pencil or something like this, it was probably a little bit faster, but I want you guys to be able to see how I'm doing it in PDF Expert, which is the app I'm using. Okay, so L1 is tied in. Now, before we do anything else, I'm going to tie neutral in. Don't want to forget about neutral, okay, sort of important. And I'm going to go ahead and tie that in. Okay, this powers our aquastat and includes all our safety devices. Now, the other device that I really have to tie in is our transformer. Okay, our transformer has to get both neutral and line. Okay, and it has to be non-switched. In other words, after my service switch, but it isn't going through any of the other terminals in my aquastat. So the easiest way to do this and show this is we're going to come over here. I'm going to take this line. Okay, now when you're in someone's basement, this is either in a junction box or it's tied to L1. Most likely there's a junction box where this switch is, and everything will come off there. Okay, neutral, we're going to pull up. And I'm going to bring around the side because you'll see what happens with the wires in a few minutes here. And I'm going to pull it over. Actually, I'm going to take that line, extend it. The nice part about working electronically is when you find a line that you need to extend, you actually can do it easily. And I'm just going to shorten that one so it looks neat. Okay, so we have our transformer tied in. Okay, from here we now have low voltage capability. We can tie all of our other controls in. Now the next thing I'm going to tie in, because it's the easiest thing to tie in, is I'm going to tie in my CAD cell. Okay, just for sake of keeping it the way you would actually see it in the field, I am going to go ahead and use yellow, because most CAD cell wires are yellow. I know it's tough to see, but the CAD cell connects to F and F. Okay, so one side of the CAD cell connects to F, the other side of the CAD cell connects to F. Okay, and the reason I use different wire colors is just because I'm crossing wires here, and different wire colors will not connect. Okay, so that ties in my CAD cell. Now, circulator is actually pretty easy. One side of it ties to C2 and one side ties to C1. Really doesn't matter which side. Okay, but I'm going to use, I'm going to go ahead and, this is line voltage, but I'm going to use a black wire just to show it's a switched line voltage. So I'm going to come down here. I'm going to tie that side to C2. And I'm going to come over here. And we'll tie that side into C1. Okay, so we have a few terminals left on here. Okay, we have a T and T and a B1, B2. Let's go ahead and get my burner, which is the B1, B2. That's my burner. Now, because we're not being told otherwise and we don't have additional terminals, the burner motor and the ignition transformer have to energize and de-energize at the same time. So let's go ahead and get that out of the way to start with. Again, I'm going to go ahead and I'm going to go ahead and do this one in blue. Okay, common. We'll just make this easy. Actually, let me undo that. I'm going to do that. Okay, so now once I connect power to this, okay, we can know that our B1 and our B2 are going to energize those two components at the same time. Be careful you never connect directly to the start winding. You only connect to the run winding. So I'm going to come out of B2. And I'm going to energize, for B2 I'll come down to okay, and then for B1 I'll do somewhat of the same thing, but I'm going to tie it into the run and the L side. Okay, this is a 120 volt circuit, so we do actually have a neutral. And to try to keep it looking as neat as possible. Okay, so that ties up our line voltage side. Now we have to just talk about control voltage. Okay, we have two zones. So we have two thermostats. They both get powered with R. So let's go ahead and give our two thermostats. Okay. Now, when the thermostat calls for heat, it's going to energize the zone valve motor through the W terminal. Because we have a motor, okay, that's considered a load, so we want to always take our loads and they go back to transformer common. So let me draw this in here so we can get back to transformer common. And you can junction one off the other, okay, as long as you're on the right side. So we're going to go ahead and do that. Okay, so now our zone valves will open. We have two final terminals, okay? Our zone valves have an end switch. End switches are always wired in parallel so that if either zone valve is open, okay, we make the terminal connection to T and T. So again, I'm going to come down here. Okay, I'm going to put that in. I'm going to extend this out. And again, because I have different color wires, just realize that there is no junction where the wires cross if they're different colors. Okay, so I'm going to come out of this one. Okay, now we've made the circuit from T to T. So the ways, let's look at sequence of operation. Either thermostat calls for heat, energizes the zone valve motor, opens the zone valve. Once the zone valve is fully open, that normally closed contact closes and allows a circuit from T to T. That's called the end switch. The end switch closes. Okay, the circuit is complete. Burner motor fires. Okay, as long as there's flame, the CAD cell will keep the circuit energized. On the burner motor, water will heat up. At a certain point, the aquastat will start the circulator. That whole sequence continues until the thermostat is satisfied and everything shuts down.